Welcome back, my wonderful students. So, in examples 3 through 6, what we will be doing is you're going to learn why completing the square is super important. So, not only do we use completing the square to solve for your x value, your x-intercepts, your roots, your solutions, your zeros. Okay, normally most people actually don't use completing the square to find the zeros or the x-intercepts or the roots. Some people do though. Remember, a good thing about completing the square is that it works every time, just like the quadratic formula. But unfortunately, it is the most disliked way to solve for the x values of a quadratic. But that doesn't mean you can't use it, okay? But anyways, the main reason why you guys need to know how to complete the square is it's useful to write standard form as vertex form. So completing the square is really good when you need to rewrite an equation in a different form. Okay, so remember, let's go way back. Sorry, guys. All right, so remember, I taught you guys standard form. So standard form is ax squared plus bx plus c. So when your quadratic looks like that, you are in standard form. When your quadratic looks more like this, so y equals a times x minus h squared plus k, you are then in vertex form. And what we're going to do is we're going to complete the square from standard form to get your standard form equation into vertex form. Remember, vertex form is very helpful because it helps you to identify the vertex point on your parabola, which then helps you to graph your parabola. So that is why it's helpful to use vertex form sometimes over standard form. Okay, and if you guys notice, the a value in standard form is going to be the exact same a value in vertex form. So keep that in mind. Now, the b and the c have nothing to do with the h and the k, but the a values are the same. So just keep that in mind. Let me go back. Okay, so what we're going to be doing, we're starting in standard form. If you guys see here, all of these look like ax squared plus bx plus c. They all kind of look like that. Okay, so we're going to start in standard form, and then we're going to use the steps to complete the square to rewrite this equation in vertex form, which is really cool. And after we get our equation in vertex form, like we did in examples 1 and 2, you guys will be identifying the vertex point, the a value, which then the a value tells you whether your parabola will have a max or minimum. And from there, we can draw a rough sketch of the graph. So pretty much, you guys, after we complete the square and get this bad boy into vertex form, then it's going to be a lot like example 1 and 2, because then we'll be in vertex form. Okay, well, before we get too far along, why don't we get started on example 3? I'm already super pumped up, so let's go. All right, so again, we're starting in standard form, and we're trying to get this equation into vertex form. So again, we're completing the square to write standard form in vertex form. Okay, and then we're going to find the vertex point from vertex form, the a value, and we're going to state whether it will have a maximum or minimum. All right, so we need to think back to those good old days when we were completing the square, because basically, you guys, it's not going to be the exact same steps to get this thing in vertex form, but pretty much it is the exact same thing. So if you think back to completing the square, then you're going to be great when we start example 3. Okay, well, let's get started. Okay, so standard form to vertex form. Now, first of all, we need to make sure all the x's are on one side, and then all the terms without x's are on the other side. Okay, and if you guys notice, we have a y value now. Okay, so vertex form does have a y value in the equation. So usually we made y 0 because we were solving for the x-intercepts or the roots or the zeros or the solutions. Okay, I just want to know what the equation is for vertex form right now. So we're not going to make y 0. We're going to leave y in the problem. This is when completing the square to get standard form into vertex form is just a smidge different. But honestly, it's not different. You're basically doing the same thing. Okay, so still the same first step. I need to move everything over that is not an x onto one side, preferably the left side, and everything that is an x will stay on the right-hand side. Okay, so I'm going to rewrite this so I can start manipulating that equation. So we have y equals x squared minus 4x and then plus 5. All right, so currently this 5 is on the wrong side of the equation. And guys, the x's and the terms without the x's don't get along. Okay, so it's really bad that the 5's here because the x's are about to send the demon cats on the 5, and that's really bad. Okay, so let's go ahead and move the 5 over to the other side, and it will join the y. So everything without x's will be on the left side of your equation. Everything with x's will be on right-hand side of the equation. Okay, so the way I move positive 5 to the other side is by subtracting it on both sides. Okay, which 5 minus 5 will cancel and turn to 0. Now, y and 5, they are not like terms, you guys. I cannot combine those together. Okay, so I just have to leave this side as y minus 5. So that one you can't combine, so I'm not going to like write anything because, well, it doesn't really equal anything. So this is just y minus 5 equals x squared and then minus 4x. Oh. Okay, now the next step is very important. We always need to make sure our a value is 1. If it's not 1, we need to deal with that. And since we have y in our equation, you guys, when a is not 1, this is the only time when completing the square is like just a little bit different when we're converting to vertex form. But again, you're essentially doing the same thing. Okay, but currently, what is the a value of the equation? Which value is in front of the x squared? Well, currently, I don't see anything in front of the x squared, which means there's a sneaky little ninja out in front. That's a 1. Okay, guys, so my a value is a 1, so that's a good thing. So a is 1? Yes, that is a good thing. Okay, so since a is 1, remember, if your a is 1, you're good to go. So now I'm going to force this side of my equation to be a perfect square trinomial. And what is that magical formula we use to force our quadratics to be a perfect square trinomial? That would be b over 2 squared. So this side will be a perfect square trinomial before too long. Okay, so I'm going to do my b over 2 squared. Okay, so that will equal, b is negative 4, so negative 4 over 2 squared. Negative 4 over 2 is negative 2. And negative 2 squared, negative 2 times negative 2 is positive 4. Okay, so like before, remember when we do this, I'm going to add it onto one side of my equation, but to keep the equation balanced, if I add it on one side, I got to add it on the other. Just like when we subtract 5 on one side, you guys subtract it from the other. We keep the equation balanced. Okay, so I'm going to have y minus 5. I'm going to add that magical number onto both sides, so plus 4. Okay, and that will equal, let's see here, this. Okay, so x squared minus 4x and then plus 4. Okay, so I've added it on both sides of my equation. Don't forget that or the demon cats will get you. Okay, so first of all, I'm going to simplify the negative 5 and the 4. So I'm going to have y, and then negative 5 plus 4, well, that's a negative 1. So this is going to be y minus 1 equals, now remember, we have forced this side to be a perfect square trinomial, which means I can rewrite this as a binomial squared. And remember, there are some little shortcuts we can use. Technically, you could factor this, so you could slide and divide. Or the shortcut, don't forget, I'm just going to do the shortcut here because I kind of am out of space. So we're going to square root the first term. We're going to square root the third term, or the last term. And then we're going to take the sign of the middle term. All right, so the square root of x squared, what times what gives you an x squared? Holy hot dog, that would be an x. And I'm going to square root the third term, which is a 4. So the square root of 4 is 2, because 2 times 2 equals 4. Okay, so I'm going to write my x and my 2 in my parenthesis, and then I'm going to take the sign of the middle term. So the sign of the middle term is a negative. So x minus 2 quantity squared. Okay, so now I'm going to bring on down my equation. So I'm going to have y minus 1 equals x minus 2 squared. And if you guys kind of see, if you look here, if you see, it's starting to kind of look like vertex form. We got this squared going on. Now, if we're going to use vertex form means y must be on one side by itself. Currently, this negative 1 is getting in the way. Okay, so I'm going to move my negative 1 to the other side. Okay, so the way that you move negative 1 over is by adding it on both sides. Okay, and I can't really add one to these, you guys. X minus 2 is all being squared. So that's like all one term. I can't like add one. I can't like squeeze the one in the parenthesis because this parenthesis is being squared. And adding 1 inside the parenthesis is going to drastically change that value. Okay, so when you add this to the other side, you're just going to add it onto the end like that. Okay, so negative 1 plus 1 will cancel and turn to 0. So my final vertex form, which I'm going to write up here, is y, this is gone now, so y equals x minus 2 squared plus 1. And don't forget, if you don't see a value out in front, that means there secretly is a 1. Okay, so for my vertex form, so if you guys see here, I kind of laid it out. So we found vertex form down here. And then now that we have vertex form, just like in example 1 and 2, I can now find the vertex point, the a value, and then draw a sketch of the graph. Okay, so let's do it, you guys. Vertex form is y equals, my a value is technically a 1, since I didn't see anything. So 1, parenthesis, and then it's x minus 2 squared. So x minus 2 squared. And then we added the 1 onto the end, so plus 1. Okay, so here's my vertex form. My vertex point is the h and the k in the formula, but don't forget the h, you got to think the opposite, which just means you got to flip the sign. Okay, so my vertex point, the h, the opposite of negative 2, is positive 2. So 2, my k value is 1. Okay, so my vertex point is at 2, 1, so I'm already going to graph it on my sketch. So 2, 1, that's my vertex point. Okay, and then, so this is my vertex. All right, and then the a value tells me which way my parabola is going to face. So my a value is a 1. And 1, is that greater than 0 or less than 0? Is it positive or negative? Well, 1 is positive, which means the a value is greater than 0. Okay, when the a value is greater than 0, it's positive, which means it's a happy face. And happy faces have minimum points. So this is a minimum. Okay, so we know the parabola is going to be facing up. So I can just approximate my parabola by sketching this real quickly. So my parabola will be facing up. So it's going to look something like that. Okay, and then finally, you guys, don't forget to name your graph. Okay, that's probably like the most important step in this whole thing. All right, so here's the sketch, and my graph's name, I'm going to name it Frederick. Looks like a Frederick to me. All right, well, that's it, you guys. Let's do example 2. Or I'm sorry, JKLOL, example 4.